Now let us look at two very important sequences. Now the first one is bounded sequence. A sequence is said to be bounded above if there exists a natural number n such that an is less than or equal to n for every n greater than or equal to 1. That is, all the terms of the sequence, they are always less than or equal to some number n. In the same way, we can say a sequence is bounded below if all the terms in the sequence, they are greater than or equal to some number m for all n greater than or equal to 1. And we say that a sequence is bounded if it is both bounded above as well as bounded below. That is, all the terms of the sequence, they are greater than or equal to some number m but less than or equal to some number n. Then we say the sequence is bounded. And one of the important properties of convergent sequence is every convergent sequence is bounded. So if there is a convergent sequence, then that sequence has to be a bounded sequence. Now let us take monotonic sequences. Now when we say a sequence is monotonic, we simply mean that either it is an increasing sequence or it is a decreasing sequence. So we say any sequence xn, which is a sequence of real numbers, is increasing if x1 is less than equal to x2, is less than equal to xn, is less than equal to xn plus 1. So this sequence, we say it is an increasing sequence. In the same way, if x1 is greater than equal to x2 and xn is greater than equal to xn plus 1, we say that the sequence is decreasing. A sequence is said to be monotone if it is either increasing or decreasing. So if we have to prove any sequence is a monotone, we need to prove that either it is increasing or it is decreasing. Now let us take up a question. It says, using induction, prove that the sequence a1 equals 1 and an plus 1 equals 3 minus 1 upon an is an increasing sequence. Now we are given that an plus 1 is 3 minus 1 upon an. Now we can find a2 and a2 will be 3 minus 1 upon a1 and the value of a1 is 1. So a2 is 2. Now our statement is the sequence is increasing. That means an plus 1 is greater than or equal to an. Now we'll prove the statement for n equals 1. Now if the value of n is 1, then we can write a2 is greater than or equal to a1. Now a2 is 2 and a1 is 1. So this statement 1 is correct. Now let us assume that let pk be true. If pk is true, then we can write ak plus 1 will be greater than or equal to ak. Now 1 upon ak plus 1 will be less than or equal to 1 upon ak. Now we multiplied with minus 1, we can write 1 upon ak plus 1 will be greater than or equal to minus 1 upon ak, and then we'll add 3 both sides. Now this is nothing but this is ak plus 2. So from here we can say ak plus 2 is greater than or equal to ak plus 1. That means p k plus 1 is true. So from mathematical induction, we can say that an plus 1 will always be greater than or equal to an for all n belongs to n. That is, the sequence is an increasing sequence. Now let us take another question. It says, is the sequence 2 to the power n upon factorial n is a monotonic, non-increasing or non-decreasing sequence? And find the bounds of this sequence. Now for this question, an is given by 2 to the power n upon factorial n. Now we write an plus 1 upon an. Now an plus 1 will be 2 to the power of n plus 1 upon factorial n plus 1, and then divide by an, which is 2 to the power n upon factorial n. Now here 2 to the power n will cancel. Now factorial n will also cancel. So we'll get this as 2 upon n plus 1. That is an plus 1 upon an, and it is equal to 2 upon n plus 1. Now n plus 1 is always greater than or equal to 2. That means 2 upon n plus 1, it is always less than or equal to 1. So from here we can say that an plus 1 is less than or equal to an. That means the sequence is decreasing sequence or monotonic non-increasing sequence. Now we have to find bounds of this sequence. Now we know that an is defined as 2 to the power n upon factorial n, and it is always greater than 0. Now we need to find its upper bound. Now we know that factorial n, it is always greater than or equal to 2 to the power of n minus 1. So in general, factorial n is always greater than or equal to 2 to the power of n minus 1. So 1 upon factorial n will be less than 1 upon 2 to the power of n minus 1. So we can write this an will be less than or equal to 2 to the power n upon 2 to the power of n minus 1. That is, the sequence is always less than or equal to 2. So from here we can say the sequence is a bounded sequence. Now here the question is, state whether xn, which is given by n plus 1 upon n, is monotonic increasing or decreasing. Now we can write xn plus 1 minus xn is n plus 2 upon n plus 1 minus n plus 1 upon n. Will be n square plus 2n minus n square minus 2n minus 1 upon n into n plus 1. Now here n square and 2n will cancel. So we'll get xn plus 1 minus xn, and it will be equal to minus 1 upon n into n plus 1, which is less than 0. So from here we can say xn plus 1 is always less than xn. That means the sequence is monotonic decreasing. Now another method to show the sequence is decreasing is by considering this function fx equals 1 plus 1 by x. Now if we find f dash x will be minus 1 upon x square. That means f dash x is less than 0. And if f dash x is less than 0, then fx is strictly decreasing. So this function fx, it is strictly decreasing function. So if we plot the graph of this function will be strictly decreasing when x is greater than 0. Now, if we look at the sequence xn, which is n plus 1 by n, it is nothing but 1 plus 1 by n. That is, it is the same function only defined for natural numbers. So if we consider the value of this function at natural numbers, then this function, it is strictly decreasing for natural numbers also. So this xn, it is monotonic decreasing.